Hello, everyone. Hope everyone's had a amazing day at the NIDC this year, and we have a special treat for our very final talk of the evening. We've got Niall Hodgens talking about disaster-driven infrastructure. So give it up for Niall.
Thank you, Connor. Um, Folks, I'm fully aware I'm standing between you and a free bar, so I'll try not to go over. So my name is Niall Hodgen. As Connor said, I'm a DevOps engineer. This talk is called Disaster-Driven Infrastructure, Picking Up the Pieces with IaC. A little about me first before we actually go into the talk itself. So I'm a DevOps engineer at Daily Pay. For those of you who don't know what Daily Pay is or who we are an earned wage access company. We provide customers, primarily in the United States, with access to their wages pretty much straight after their shift or at the very latest the next day. So this cuts out this payday loan racket that's been going on for many years and gives access to money that's been earned for people who are potentially desperately in need of it. So it's a very worthwhile cause. I was a secondary school teacher for 9 years. Bonus point that if you can tell me afterwards what subject I taught. And I'm also a golf addict. So I've got 3 kids now, so don't even ask me what my handicap is. It's been slowly creeping up. So what this talk is, I want to make this very, very clear. This is an overview of how IaC can help teams prepare for disaster. Okay, IaC, for those who are uninitiated, is infrastructure as code. And we'll talk a little bit more about that. Specifically, I'm going to be doing a demo later. It's going to be based in AWS using Terraform. What this talk is not, it's not some sort of magic formulation for a DR plan. That would take a couple of conferences with multiple talks to cover that. So don't be expecting some sort of magic formula for that. This is an overview of disaster recovery from the perspective of someone who is in the front lines as a DevOps engineer. For those of you who don't know what a DevOps engineer is, you've maybe heard the name bandied about. You've heard the term DevOps. It started off as a philosophy. Sounds very highbrow, but it's not really. But I like to think, so my colleagues and I were talking about this, and I like to think of DevOps engineers. We look after the infrastructure. So think about the Sydenham bypass currently. If you're having to drive that stretch of road normally and you're fighting through that traffic as it currently is with all the roadworks going on, you're probably cursing under your breath the people doing the work. That's kind of like us when things go bad. But when things are going well, DevOps engineers who look after the infrastructure, we're like invisible. That's the way we want to be. People don't, it's kind of like, it's not thankless jobs as such, but we're kind of invisible in that sense. And that's kind of how you know you're doing your job well as a DevOps engineer. That's my interpretation anyway. So before I actually go any further, so this is based on infrastructure as code. Specifically, I'm going to be talking about Terraform. This could apply to any infrastructure as code tool, just to get a gauge of where everybody's at in terms of that. Hands up if you know what Terraform or infrastructure as code is. Okay. Ironically enough, here at this talk. Hands up if you have ever used Terraform or another infrastructure as code tool before. Hands up if you've used one of those tools this very week in work. Okay, so people will have a good understanding. That's great, because what this talk is, it's not necessarily a deep dive into Terraform and how to set up some sort of multi-region setup. There is an element of that. It straddles the divide between the kind of theory side and the technical side. So disaster recovery. Let's get a working definition out there, because it can mean several different things depending on what perspective you're coming from. So disaster recovery, according to Google Cloud, is an organization's ability to restore access and functionality to IT infrastructure after a disaster event, whether natural or caused by human action or error. So, very obvious, but we'll have to state it here. Here are some of the most common categories of disaster. We have network outages, bugs, human error relates to bugs, of course, and cyber attacks. So just to give you some context, how big of a deal is disaster recovery and having a great resilient infrastructure and disaster recovery plan as a company and even at a development team level? Well, let's take the Fortune 500, for example. Parametrics, who carried out a simulation and produced the results of this study, based the simulation on the Fortune 500 companies, how much they would lose if, for example, there was an AWS US East 1 outage for 24 hours. That would be $3.4 billion worth of damage. $17.5 billion, That would be if AWS US East 1 and US West 2 had an outage for 48 hours. The reason those are selected is because they're the most popular regions for AWS customers. And then looking at Azure as well, to move away from AWS, $3.1 billion. That's if Azure Central US, East US, and East US 2 had an outage for 24 hours. So hopefully that provides some context as to the seriousness of this. So it goes without saying, disasters are inevitable. Did anyone here in July, were you affected by the Cloudstrike outage? Anyone? Yeah, a few heads nodding. Okay, that was a human error, bug introduced. Windows systems were affected by that. The top one, I don't know if any of you are familiar with it, you maybe don't want to say, but Ashley Madison cyber attack. Anyone involved or that? I'm only joking, you don't have to raise your hand. The reason I bring that one up is because it's very relevant. It's a cyber attack, but it was Netflix had released a documentary 6 months ago. I was intrigued. My wife and I had watched it and we were intrigued. The grey area morally, of course, but also the cyber kind of tracing back the kind of pinpoint cause and not to ruin it, but they couldn't figure out the exact person, the perpetrator behind it. And the last one relates to the Mars Polar Lander. 1998, NASA had spent millions of dollars, as they always do, of course, trying to create this experimental robot that would be launched in the orbit, reach Mars, gather some information, some telemetry in the weather of Mars, and then fly back to Earth with that data. Unfortunately, at the kind of climactic part of its journey, it ended up disintegrating in Mars' atmosphere. The reason? Human error. It was a bug. There was a subcontractor NASA had hired to write some of the code in the background. They had specifically asked him to use European metric units. NASA being American based, of course, he just presumed that he was going to use American imperial units. What that meant was the bug in the code made the polar lander end up going completely off course. And it was a complete disaster. So that's a famous one from 1998. So like I was saying, disasters are inevitable. Whether it be cyber, IT, personal life, take it philosophically if you want, you've got to prepare. So as a bit of an aside before we get into the demo, we're talking about how IaC can help prepare for disaster. There are some other ways that we can find some blind spots in our infrastructure, how we can dive into the way our company sets up our systems and trying to figure out where the weaknesses are. And one of them, ironically enough, is to play games. Has anyone here ever played the game Risk or heard of the game Risk before? Yeah. You play it once or twice, you realize how long it is. You probably never play it again, even though it is a fantastic game all the same. But it's like a military board game. You've got to conquer the world. And quite literally, for the last century, Western militaries have actually introduced this into their planning. They will sit round tables, the top brass of the military, and they will be given a bunch of cards, different scenario, pick one at random, and they will sit down and flesh out over a board game what actions they're going to take. And it's not just military people, it's people from all sorts of experts from all disciplines. This has actually, moved its way into the cyber world. There are actually competitions in the cyber world. The UN run one, and it's quite highly competitive. But companies in their boardrooms, different things have implemented this as well. So that's another suggestion I would have to kind of think about. At the end of the day, it's a good excuse to play a board game, if nothing else. But one of the case studies that RAND, Research and Development Organization in America, when they carried out one of these was, I was listening to a podcast. This was Malcolm Gladwell's Revisionist History podcast, for anyone who's heard of it. And he was talking about how they ran this scenario where North Korea, there was a military coup. And long story short, they had to think about the nuclear weapons gone awry. They had to think about all the different scenarios that could unfold. And one of the things that they did not think about was the fact that Seoul in South Korea, when people were leaving Seoul, there would be a flood of traffic. But they wouldn't get anywhere because there would be a complete gridlock. Okay, so that outside of the cyber world, of course, but it kind of points to the fact that there are weaknesses in our infrastructure that we can't see until we run these kind of simulations. Microphone's going. Can everyone hear me? Okay, yeah. So key question, back to the point. Why should IaC be leveraged to increase our preparedness for disaster? So 3 key things I want to impress upon you today if you're not already doing this. IaC, when it comes to DR, can help with fast rebuild times, easy replication, and it can simplify multi-region. Okay, every company in this day and age wants to kind of aim for that multi-region setup. And the reason for that is obviously the resilience. side of it. AWS is this well-architected framework. Azure and GCP have similar. And one of the key tenets of all of those is resilience. And one of the ways that you can make your company and your systems more resilient is through this multi-region approach. Some people who are cynics may think, well, that just gets them more money. Of course, there is an element to that. And I'm going to come back to that later on, because you don't necessarily need to make every single service in your company multi-region. That, to be honest, would just be silly. So, some disaster recovery architectures here. Let's see if I can zoom in. Okay, so we have active, which is the first one. This is like the most expensive, but the most resilient. They kind of go hand in hand. This would be for possibly your key services. Okay, this is where you have traffic that is routing to 2 regions, and both regions are completely live. So at the simplest level, you maybe have a load balancer in each region. You have a DNS set up, a bit like my demo I'll show you. It's going to be routing traffic live, and it could be geo routing the traffic. So depending on where that customer is, you probably want to route them to, an AWS region in the US, Azure, whatever. Same kind of thing. Active passive. This is where you have 2 regions with your infrastructure set up. You maybe have an EKS cluster or some sort of ECS setup, whatever it is, in 2 different regions, but one of those regions will be kind of lying dormant. There are different variations to this. You can have it literally lying dormant where it doesn't start up until you need it to, or you can have it kind of sitting, running warm, ready to go, but there's no actual traffic going to it. So essentially you have region A where the traffic's going to live, you have region B where it's kind of sitting there waiting, ready to go. And this one may seem obvious, and I would like to think every company in the world today is doing this, but at the very simplest level in terms of a DR kind of architecture strategy, you should at the very least be backing up your object storage, your databases, and various things like that. Oh, I've died again. It's just not meant to be. Someone's looking at their free bar. There we go. Oh, this one. Oh, there we go. Back. We're live. Sorry, excuse me. Microphone's throwing me off. So yeah. So we're going to do a demo. I am going to talk through the architecture very briefly. The architecture doesn't really matter. It's just to kind of show you an illustration of how simply we can set these things up. We need to talk about regions in case anyone here isn't versed. Whenever we're talking about cloud infrastructure and cloud providers, they all use this similar terminology about regions. A region is literally a geographical, physical region. Okay, that could be in Brazil, Sao Paulo. That could be in, US East and Virginia. Inside each region, you have what's called availability zones. So let's take the US East one, which is based in Virginia, in the east coast of America. You will have literally data centers that are clustered in these availability zones, spaced out 30, 50 miles away from each other. Okay. So my architecture setup here, it is relatively simple. Let's work from kind of back to front. So we have replication that's set up. This is all through Terraform. Replication setup of KMS keys, S3 buckets, secrets manager. Okay, that's replicated to US West 2. So this is US East 1. This is US West 2. Okay, this is all linked to the EC2 instances here, which are in a private subnet using a round robin algorithm for the load balancer. That really doesn't matter. There's various things. Okay, right. So everyone can hear me okay though, right? So we have the EC2 instances. I've just chosen to do 2 because I'm just keeping it simple and I don't want to run up a massive bill. Then at the front, we have a public subnet. This is our entryway to the internet. This is where customers are going to access what is, you will see in a second, a static website. So this is where the application load balancer lives, and that is what feeds the traffic across. So this is where the magic happens. AWS have this DNS service called Route 53. And Route 53, this, like I said, is where the magic happens. You go to the failover DNS record, and I'm going to show you what this looks like in Terraform and show you how simple this is to set up. The complexity of this can go up depending on what you're trying to deploy and what your current systems are. But this is just to show you how easy this is to do in infrastructure as code, whether it be Terraform, Pulumi, OpenTofu, or whatever. So this is what the failover record does. You've got the primary region up here, and you've got a secondary region. And what you're doing here is you're setting to, you can do it in CNAME records. I've chosen to do A records. So I have 2 A records. One points up here to this load balancer, one points down here. One's labeled as primary and one's labeled as secondary. Okay. And I'll come back to this in a second. So I am using we're back again. I'm using a very cool tool that AWS provide. Azure and GCP have similar services as well. AWS, it's known as the fault injection system. What this allows us to do is obviously inject faults in our services. Very, very cool. Not a really costly thing to run. This falls under the category of chaos testing, and I'm going to come back to that while the demo is actually running, because there's a period of about a minute or so where you just see these curl commands going, and I'm going to talk a little bit more about it. But essentially what we can do is there's loads of different scenarios. You can choose, like if you're using EKS, you can do a stress test on it. EC2 in my instance is what I'm doing. You've got these experiment templates then that you can base off these scenarios, or you can set them up totally from scratch. Anyone familiar with AWS, you can literally go on, pick your service that you want to perform some sort of test on, and you can choose what particular actions you want it to do. So in this case, I'm doing an EC2 stress test. Start experiment. Okay. I'm going to do a make curl. Probably got a bit ahead of myself there, but you'll see there's 200s. I'm also going to show you the website that I have built using some bootstrap templates. You can see, so it went from this. We'll reload it. We get 502, bad gateway. Got a bit ahead of myself. What I was meant to show you there as well was that at the very start, inside the website itself, I've actually used the EC2 metadata API to output the region that particular EC2 instance was living in. So if anyone had a quick eye there, you would have seen that it was in US East 1. Whenever this loads back up, you're going to see that it switches to US West 2. So apologies for getting ahead of myself there and letting people miss that. But back to chaos testing. So while this is going on, the fault injection service falls under the realm of chaos testing. For anyone who doesn't know what that is, Netflix kind of made it famous. They had this tool called Chaos Monkey, and what they would have literally done and what they became famous for is they would have ran this in production workloads essentially at random. So imagine being on one of the dev teams in Netflix, working away, thinking this is great, and boom, you start getting all these alarms. Your production systems are gone. Some of you might be triggering PTSD here, but the fact is, chaos testing, yes, start small, work your way up the environments, but essentially the most you're going to get out of it here is going to be whenever you're doing it in production eventually. So you kind of have to work your way up in terms of your bravery and test it out. But it's meant to try and find weaknesses. It's not to point fingers. Sorry, it keeps on popping here. It's not meant to be a finger pointing exercise. It's meant to establish the weaknesses in your systems. So let's see. Please don't be lying to me. It gives me fear every time. I've done this several times. Yep, there we go. That was one of the quickest ones. So it's reloaded. And apologies I didn't show you, but it did say US East 1B or 1A before this. Now you can see it switched to US West 2B. Okay, so if anyone wants to jump on that website as well, then for me to prove that it's actually real, you can use that QR code if you want as well. So back to the presentation. So how does this all get implemented in IaC, infrastructure as code? So I've used Terraform. You don't have to, like I've already said. Whatever infrastructure as code tool you want, really. Terraform, for those who do not know, it's a stateful tool. So CloudFormation, for example, doesn't save the state, it just creates it and it's done. Terraform keeps the state in the back end. It means that you can keep track of things. If someone was to go and change something manually through the AWS console and you ran your Terraform plan again, you're going to see that drift in configuration, and Terraform's going to not be very happy and want to change it back, which for anyone who works with it on a daily basis knows how much of a headache that is, and it's a problem that hasn't been solved, but that's one for another day. Your kind of Terraform directory layout is similar, probably in most cases, to what you see here. There are various ways that you can do it. There's not one size fits all, because it is cloud agnostic and has to kind of be flexible across all the different main cloud providers. There's no real, there are certain standards, but it's very difficult to do some sort of brushstroke standard across things whenever everything's so different. So how do we, well, firstly, some cool things that we do at Daily Pay. So our Terraform setup, I would say, is quite sophisticated. It's pretty cool, some of the stuff we're doing. But we use this Cloud Posse module. For anyone who doesn't know what Cloud Posse is or who they are, they're third-party provider of Terraform modules. I think they are a consultancy, but they do offer a lot of stuff for free. We have done a bit of a rip-off of theirs. We've used it, but edited it to suit our purposes. We have used one of their modules, and what this allows us to do is to standardize naming of our resources right across our cloud infrastructure. Now, that may not seem like a big deal, but it allows us to standardize tagging and everything. It allows us to make sure that naming conventions are strict, and that means that we can quite easily write our own custom scripts based on the fact that we know what the naming convention is. It allows us to, be able to do those kind of things that we wouldn't otherwise be able to. And if anyone wants to chat about some of that after, I'm more than willing. Don't have time to really go into today. Back to the multi-region setup that I demoed there. So in Terraform, you essentially have to declare your providers, whether it's GCP, AWS, Azure. You have to declare what region it's in. And that is for a very obvious reason, because you want to specify quite clearly, I want all of these resources created in US East 1. I want all of these resources created in US West 2. A provider as well is like a binary that gets downloaded that is essentially it's used to do the API calls to create the resources in the first instance. So depending on who your cloud provider is, that's going to be downloaded and used for the API side of things. So some very quick things we can do. We can create KMS replica keys in resources. We can do S3 bucket replication. All of these things that if you were to set them up manually, which I'm going to come back to in a few slides from now, if you were to do this all manually, this would be very time consuming. It also means that every time you have to go and do it manually, it's a rinse repeat. It's wasted effort. And we all know, all of us who work in this industry know how important that principle of dry, don't repeat yourself is. So it applies here. We can simplify the modularization of things as well. You can see over here, we've got different apps that we declare, and you can see I'm passing in config for US East 1. I'm saying give me 2 EC2 instances, US West 2 the same. This is very basic. If I had an EKS set up, ECS or whatever, I could configure this to do the same thing, spin up X number of different nodes, pods, whatever. And you can see at the bottom, I'm using the providers here. I'm passing in explicitly that I want to use these providers, and it knows what to do with them and what resources to create in which region. So like I said earlier, this is where the magic happens. DNS. So Amazon Route 53, you have on the left the primary record, and it's pointing to the load balancer in app US1. You can see the zone ID given here. You can see the alias name and so on. And you can see I've got a target health check set up as well, which tells me this isn't healthy, which means I need to fail over to region B. And you can see here the secondary region record is set, and it's the same setup, but this time it points to the US West 2 zone and the US West 2 ALB zone ID and DNS name here. So, like I said, this isn't a deep dive into Terraform. It's more just an illustration of why we should be using IaC over this whole ClickOps philosophy. There is still a lot of ClickOps that goes on, and for those who don't know what I mean by that, that's literally going on the AWS, going on the console. I want to create a load balancer, click, 20 clicks later or more, you've created it. Whereas in Terraform, yes, there might be a little bit more time investment at the very beginning, particularly if you're just new to Terraform, of course, like any language. But what that means is you can repeat that over and over. If something happens to your infrastructure, there's some sort of corruption, deletion, whatever, you can just run that Terraform plan and run that Terraform apply again, and it will spin up a new resource of whatever is needed at that particular point in time. You imagine having to go through the console and do that. Imagine you've got a production outage, and all of a sudden you're scrambling around going, I need to do this, I need to do that. One of the beauties of Terraform as well is if my load balancer ever changes DNS name, Terraform will pick that up automatically because it's already in the code. You've got the whole, basic input-output values down here. If that DNS name ever changes, I don't ever need to change this code because it's picked up automatically. If you had to go and change that manually, it could be a bit of a headache, to say the very least. So this is what I'm trying to say. Every single time, in my opinion, IaC wins. There are exceptions. Imagine you have to make a change on the fly because someone's trying to, break into the company's systems. You maybe have to do a deny on someone's IP. That's something that will need to be done and maybe trued up after. Or for anyone who's familiar with Terraform, you can maybe do some sort of ignore changes in that. So that list is kept on like a rolling basis where you can add to it manually. That would be one example. And there's some more, but that's not the norm. Okay. So with that, there are some dangers that I see. Okay. With great power comes great responsibility for all the Spider-Man fans out there. And what I mean by that is we had a particular situation in Daily Pay without going into the ultra specifics of it. One of our key services, we have 4 key services. One of our key services had went down. And it was a result of human error. It was essentially someone had tried to set up a new Terraform environment that lived in one of our production accounts. And what they'd done was copied and pasted the production environment stuff, changed the name a little. What did they do? They forgot to change the back end key. For anyone who's familiar with Terraform, they will know, oh my days. Anyway, so what happened was the Terraform was ran. There wasn't very much visibility on that plan, and that person unknowingly overwrote the entire production state file. Yes, crisis. Thankfully, there's some deletion protection that you get included with a lot of the key resources like load balancers, RDS, and database instances and so on. But it still was a terrible situation and meant that our clients, the customers, didn't have availability at that time. So the irony of this was Terraform, in some ways, I don't think Terraform caused error, it was human error, and that can happen with anything. But the beauty of it was the Terraform solved the error as well. A few of my colleagues were quickly able to get around a call on Zoom and spin things up again. Now, being totally honest, it wasn't just as simple as doing a Terraform apply. Anyone who knows working with secrets and different things, you have to make sure that the secret's not pending deletion, all these different things that can trip you up. But for the most part, the infrastructure was spun up with a few tweaks that were needed to be done manually. And that's a very complex system that we're talking about here. Not something simple like my demo. So what do we do to remediate that? For anyone who maybe is thinking about ways they can kind of guardrail their Terraform plans and applies better, we run through PRs that our Terraform plans spit out that code to. But what we didn't do previously was add this table. We had this where you clicked it expanded and showed you your plan. But we added this to the backend GitHub action that spits out, what's being added, changed, destroyed. It also tells you like, if over 40% of your state file is being deleted, chances are you probably don't want that and your attention needs to be brought to it. And it also, if you're trying to delete a key resource, even if you're only deleting one thing and that one thing is an RDS database instance, do you really want that? That's why we're flagging it up. So we also added back-end key validation. This means that if people copy and paste something that already exists, it will be flagged up, but also we've enforced naming conventions for things. People were kind of going a bit rogue for a while just because there's a bit of disparity between different Terraform environments. So this was one of the ways that we did to guard against that, and that was built into the backend GitHub action as well. So key takeaways. IaC, infrastructure as code, it is king. It can really help you with your disaster recovery. I think in this day and age, it is something that if you're not already doing it at a company-wide level, it's something that you really need to be thinking about. Think about the amount of time wasted doing this ClickOps stuff, creating stuff, all of the pitfalls of that. So that's why I've put ClickOps as for chumps there. But there are exceptions, of course. But with great power comes great responsibility. Secondly, aim for multi-region. I talked about this earlier. If your service is a key service for end users, you should probably be aiming for multi-region if your company has the budget. If it doesn't, maybe think about active passive. If it's internal services that, aren't overly important if they went down for a period of time, is it worth wasting the money in multi-region? Probably not. Definitely not active. And then chaos testing. For a lot of people in the room, it's probably something that you've heard of, that you've never actually tried. I encourage you. I dare you. Try it. Don't go doing an April Fool's in production or something like that with your engineers. That wouldn't be very fun. Although I did talk about that jokingly, of course. But that is something to think about as well. And lastly, some food for thought, because we haven't found all the answers. I do truly think we're doing things pretty well in Daily Pay in terms of infrastructure, but there's definitely improvements that can be made as in all companies. And how can we better guard against unwanted infrastructure changes? So some food for thought there. And then lastly, what other ways can we identify weak spots in our infrastructure? I talked about playing board games, okay, doing war gaming as it's called. What other ways are there that we can do this, both at a development team level and at the C-suite level? It doesn't matter. There's definitely ways that we can all be taking part in that process of identifying weaknesses. That's really all from me, but if anyone wants to get the slide deck, you can use a QR code. There's some AWS docs listed there and some that parametrics reference too. You can go on that report. But thanks very much. You've been very gracious considering the fact that I'm the last talk of the day. And yeah, thank you guys. Appreciate it. Any questions from anyone?
Thank you for the great talk. I just wanted to ask you, how do you balance keeping the recovery plans simple yet comprehensive enough in the worst case scenarios?
That's very hard. Like I said at the start, that's something that probably is outside the remit of this talk. In terms of the infrastructure side of it, I mean, we don't have specific playbooks to things, but I think it would be a good thing for us to implement potentially, playbooks and these things. But really what this is, disaster driven infrastructure, is, thinking from day dot when you're building your infrastructure, how can we make this more resilient in terms of actual specific plans and playbooks that you run? That's something that's probably done at a higher level than what I kind of have the time for in this talk, but yeah. Everybody, thanks very much, guys. Appreciate it.